Now, beyond biases, we also seem to take decisions using heuristics. Now, heuristics are sort of rule of thumb kind of ways to reach conclusions. And obviously, they serve a purpose of decreasing computational complexity. I mean, if you think about it, what expected utility theory is saying is that you look at all the possible options that you like, you rank every single option, you kind of get an understanding of how likely each option is to give you a certain outcome, which has a certain value to you. And then sort of you can get through this whole calculus to find the very best option. Of course, this is unlikely to be what you do when you're choosing between different options. And so one way to not have to put up with all that computational complexity, and one way to cope with the computational complexity of having to make decisions, is to adopt these kind of shortcuts, rules, such as heuristics. Now, one very well-studied heuristic is known as the availability heuristic. And this is the tendency to rely on information that comes quickly to mind when making a decision. The idea is that we often use how easy something comes to mind when we try to think about it. We often use that as a proxy for how frequent it is. Here's the classic example by Kahneman and Tversky. What do you think? Are there more words that begin with the letter K? Or are there more words that have K as the third letter? Now, most people say that there are more words that start with the letter K. However, the truth is that there are twice as many that have K in the third position. However, it's just kind of hard to come up with examples of words that have K in a third position. On the other hand, very easy to come up with examples of words that have the letter K as their first letter. And so just because of this, of how available these examples are, people tend to infer that there are more words that start with the letter K than words that have letter K in the third position. Now, Liechtenstein and colleagues investigated people's perception of the risk of deaths from various causes. And so what they did is they presented pairs of potential causes of death, say tornadoes versus asthma, and they asked participants to decide which of the two was more prevalent. Now, they found that for certain examples, people were actually way, way off. In fact, as one example, more than half of the participants rated tornadoes as being a greater cause of death than asthma, when in fact, asthma kills 20 times more people than tornadoes. But of course, we don't often talk in our newspapers about asthma, whereas tornadoes are on the news all the time. So it makes sense that this kind of an example of a death by tornado might be much more available to somebody if they think about it, compared to someone suffering from asthma. And this is actually a pretty general point. Our perception of probabilities, our perception of events happening is actually not great. And this, of course, again, brings into doubt whether we're even able to perform something akin to the expected utility theory. For example, take these three means of transportations. What do you think are the more likely, which is the most likely one to lead to an accident? Definitely car, 1 in 18,000 versus 1 in 354,000 and 1 in 500 million in airplanes and 5-mile bus rides. Nonetheless, if you look at the American population, some 6% of Americans have fear of flying, but there aren't 6% of people who have fear of going in a car, right? So despite the fact that you're way more likely to get injured or die from a car accident, they're just not as salient and not as scary, presumably, as aircraft accidents. And therefore, people develop fears of flying, but not fears of driving. How about what's the risk of being eaten by a shark versus hit by thunder? Turns out you're way more likely to be hit by thunder than to ever be eaten by a shark. And yet, very few people develop phobia of thunder. Many people have fears of sharks. Similarly, are you more, what's the more likely cause of death? Homicide or suicide? Turns out we're all twice as likely to die by suicide than by homicide. In fact, I mean, and this is also the reason, sort of this lack of appreciation for these possibilities is also the reason why people end up playing things like Mega Millions. And if you think of it, what is incredible is that you are incredibly more likely to win the Mega Millions than to ever be eaten by sharks. And yet again, people have have paralyzing and very real phobias of being eaten by shark. In fact, you're more likely to win the Powerball at 1 in 80 million than you are to be eaten by a shark. Again, showing how our appreciation for probability is definitely not well rooted in the actual numerical probability of something, which makes the chances of me ever going out with Zoe Deschanel look pretty good. Now, why do people do this? Why do people have this skewed perception of certain risks, of the likeliness of certain risks to occur? It turns out there probably are two main factors. First, if people know personally somebody who has experienced that cause of death, that definitely usually leads to overestimating the likeliness of that particular cause of death. Second, it really depends on the prevalence of stories about that particular cause of death in the media. Indeed, newspapers are way more likely to cover, sensational causes of death as compared to less exciting, but also much more prevalent causes of death. And so this gives you the perception that a certain cause of death that might not be as prevalent is very prevalent because it is often reported in the media. In fact, much more so than causes that are more prevalent but less exciting. And indeed, Riddle in 2010 found that people who were exposed to violent media do rate violent as being more prevalent. So again, this is an example of how we make use of how available information is to us when we think about it, how available rather examples, how easily examples come to mind when we're trying to think about something. And we use that as a proxy for how likely they are to occur. Now, a related or perhaps an extension of the availability heuristic is known as the affect heuristic. Now, the affect heuristic is the tendency for people to overestimate the risk of events that generate a strong emotional reaction, such as dread. Now, the idea is that the more a certain risk, generates sense of dread, the more likely it is rated to be highly prevalent. And see, this might be an explanation of why people, despite their actual chances being something like 1 in 300 million, this might explain why people are much more afraid of sharks than they are of drowning, when drowning actually far surpasses as a cause of death being eaten by sharks. Another example of heuristic is the so-called anchoring heuristic. And this is the tendency for people to focus and to rely upon initial pieces of information. What we mean by this is that sometimes it happens that some irrelevant number ends up biasing your perception of the value of something. Let me give you a couple examples. So in a classic example by Tversky and Kahneman, participants watched a roulette wheel that was fixed and that would either have landed on a high number or on a low number. Now, after having observed this, participants were asked to make an estimate about a question that they we're unlikely to have much knowledge about. For example, what's the percentage of United Nations countries that come from Africa? Turns out, people that had seen initially a higher roulette number estimated a higher number of nations compared to people who had seen a lower number in the roulette. So, in other words, that initial number on the roulette, completely irrelevant to the task at hand, completely irrelevant to the idea of then having to estimate something. That number ended up serving as an anchor. And if you just happen to have seen a high number, you will guess a higher number in the subsequent question. If you happen to have seen a lower number in the roulette, that will just make it more likely that you will guess a lower number. So a completely irrelevant number ends up changing your perception of something, ends up changing, your estimation of something. Now, similarly, Ariely and colleagues asked participants before a task to name the last 2 digits of their social security number. Now, turns out, then they asked participants, prices about how much they were willing to pay for certain items in an online auction. Turns out, the last 2 digits of the social security number of each individual correlated with the price that eventually they were willing to pay for certain goods. So again, in this example, a completely manifestly irrelevant number, the last 2 digits of somebody's social security number, actually affected somebody's assessment of how valuable a certain item is. No doubt, once again, this clearly shows that the way in which we think does not conform to the normative view of expected or subjective utility theory.